Hi children. So again I am continuing today the polynomial chapter in which the exercise problems, that is exercise number 2.2. So already we have discussed in our previous class, that is the relationship between the zeros of a polynomial, that is zeros and coefficients of its polynomial. So under this we have to discuss the several problems on the coefficients of the polynomials. Now let us take one by one. Observe carefully. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Dear children, you already know that by linear polynomial, that is generally ax plus c or b also, because constant can be represented b or c. That is why it is the general form of the ax plus b. Okay, ax plus b. Here a is not equal to 0. Now consider for quadratic polynomial. For quadratic polynomial, that is p of x, it is equal to ax square plus bx plus c. See, consider here also where a is not equal to 0. It means the polynomials, these variables and as well as the coefficients a, b, here also a, b and c. So what is their relations? We written already. The sum of the two values goes to 0. Whenever the polynomial becomes 0, consider alpha plus beta. Consider their product, means the alpha and beta are the two different values. Consider their sums. What it shows the relation? Minus b by a. Another one is c by a. So this is already we derived in our previous class. This is the most significant relationship between the given numbers and as well as the coefficients of the given polynomial. So according to this, we have to solve these problems. Now let us take. Now consider the solution for the first one. X square minus 2x minus c. Yes, it is of the form ax square plus bx plus c, means quadratic polynomial. So now let us take the factors of this polynomial to find. In order to find the zeros of a polynomial, we get the alpha and beta. No, the sum of the two numbers and the product of the two numbers, their relations. For this, first factorize the given polynomial, that is x square minus, this is middle term. Look over here, this is middle term, and the last term, the product of the a and c is a. Consider their sign also, plus into minus. So now the product must be 8 and the sum must be 2. So which is that? That is 4 and 2. The real numbers are 4 and 2, or integer also. So consider their sign also. For the first, minus 8 will become minus. Okay. Here it is 1 plus. 1 plus and 1 minus. Because minus into plus minus, 4 into 2 is 8. The sum of these two signs become minus, because highest number contains the minus sign. So that is why the total sum become subtraction. That is why 4 minus 2 will get minus 2x, because highest sign is 4. So now 4x plus 2x minus 8. Okay. Take the common factor for the first two terms, x and minus 4, because x square divided by x and 4x divided by x. So what is left now? X minus 4. Now for these two terms, take plus 2. Consider always the numerical coefficients and the least number. That is why I took the plus 2 here. Suppose you can take it, it is not possible to factorize it. That is why plus 2. So 2x divided by 2 means x. So plus divided by minus means minus. 2 4s are. So look where. So what is the common factor here again? X minus 4. And what is the remainder? X plus 2. Consider this polynomial factors are x minus 4 and x plus 2 by using the factorization method. Now let us assume x minus 4 is equal to 0 or x plus 2 is equal to 0 for zeros of a polynomial. For this zeros of a polynomial, we should consider x values only. That is why at last x values. Now x value is equal to 4 or x is equal to -2. At 4 and this values, at x is equal to 4 or -2 only, this polynomial become 0. So that is why now consider their relations. Now I already find their factors and the values at the x values. Now I will take their sum. The sum of the numbers upon, that is alpha plus beta, it is equal to minus b by a. Otherwise we can substitute these values. Alpha plus beta means the 4 plus -2, 4 plus -2, so it is 2 only. Consider their product, the product that is alpha into beta for quadratic polynomial. Okay, so that is 4 into -2, so that is equal to 8. Now try to consider their relations. How you can consider? You know that already alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. So now minus b by a. Consider these two can be represented as minus of -2 divided by 1. Minus of -2 divided by 1, and see this one, c by a, already it is 8 minus a and divided by 1. Okay, so here 8 only means 8 is already, so instead of taking the polynomial, consider it is 8 by 1. So assume here a is equal to 1, here a is equal to 1, and b is equal to -2, and c is equal to 8. So these are the values satisfy these expressions, like sum of the zeros, okay, sum of the zeros and the product of the zeros values. Based upon these values, we should consider this minus b by a is nothing but it is a coefficient of x, and it is a coefficient of x square, and this one coefficient of, it is not a coefficient, now only constant because it is a c value, and it is coefficient of x. Hence, this is the solution for the first one. Now consider next one, that is third one I want to take over here. So third one, that is 6x square minus 3 minus 7x. Consider their standard form. Of course, it is a quadratic polynomial. What happens standard form? That is cx square minus 7x minus 3. Now it is standard form because quadratic polynomial can be generally represented as x square, bx and c. Therefore, x square plus bx plus c. Now, the same method, that is factors in. That is 6x square. Split the midterm. That is by splitting the midterm. That is minus 7x. And the last one is 18x square. So now split these terms. Of course, plus into minus is minus. It become minus. Consider 9 and 2. Consider 9 and 2. Okay. 9 2s are 18. Subtract 2 from 9, you get 7. So that is why 9 and 2. Now consider their sign. Sign is very important. Here we require the product sign is minus and the sum sign is minus. So both, suppose you put the both numbers having minus sign, it become 9 and 2. 9 2s are 18. Minus into minus become plus. 1 required minus. That is why plus. So 1 minus and 1 minus. Minus into plus minus. Now sum of these two numbers become also minus. So therefore, on subtracting 9 2, we get 7. So that is why equation satisfied. So that is 7x can be written as minus 9x plus 2x minus 3. So now 6x square minus 9x. Again take the common. Which is the common? Suppose you take least number 6, it is not possible to divide this one. Suppose you take 9, it is also not possible. Take the common factor of 6 and 9 is 3. Because 3 into 2s are 6. 3 into 3s are 9. Where 3 is the common factor. That is why. Now, and also take one more x because x both in the both terms x is there. And consider 3x square means x. 2x it is because 6 can divide by 3 means 2. and x divided by x means 2x. Now minus 3x divided by 3x means it is 3. So 1 over. Now take another one. Consider plus or minus whatever it may be, plus 2. Okay. Suppose you can take plus 2. So what happened? So here also 1, because 1 and 2, these are the prime number. If the least number is possible to divide these two terms, you can take the 2 or 3. But it is not possible. That is why 1 is the HCF of prime number is 1. That is 1. Now 2x minus 3 remains. Therefore consider their common factor 2x minus 3, and the left of the terms is 3x plus 1. Now, so therefore 2x minus 3 is equal to 0 or 3x plus 1 is equal to 0. Therefore 2x is equal to 3 or x equal to 3 by 2. One solution over. Next, similarly 3x equal to minus 1, and hence x is equal to minus 1 by 3. Therefore the x values are 3 by 2 and minus 1 by 3. At these two values the polynomial becomes 0. So that is why now I correlate these values to the coefficients. How I correlate? Look over here, the sum. The sum means alpha plus, I want to write directly because you know that the sum of the two numbers and the product of the two numbers. So now alpha plus beta, it becomes minus. So what is the numbers over here? 3 by 2 plus minus of 1 by 3 plus minus of 1 by 3, because it is an integer of primitive. So that is why. So take LCM is 6, because 3 2 prime numbers automatically become LCM 6. Now 2 3s are 3 3s are 9 plus 3 2s are 2 into 1s are minus 2. Answer is 7 by 6. Okay, 7 by 6. And the product of the zeros given number, it is 3 by 2 into minus 1 by 3. Automatically this cancel because numerator and denominator. So what left now? Minus 1 by 2. Now consider how you consider the given numbers. It is 6 and it is 2. So suppose if you multiply this one by 2, 3 and 3, then what happens? This is 3 1s are, 3 2s are, like this happens. Okay. So based upon this we can correlate the problems. In the same way, alpha plus beta is equal to also minus 1 by 2. Means here I took extra word. Means 7 by 6 is also nothing but this simple solution, because 9 minus 2 will get 7. And here it is, instead of the adding I took the LCM, that is why it becomes 6. Suppose you want to simplify it again, you can simplify and further you can get the go through the relation. Here we required only 6 only. So I could stop here only. If you simplify it again, it become further simplification. So that is shown in the next class example also. Here 6, but we want here eliminate any one, either 6 or 2, because we require that A value is 6 and B value is 7 and C value is minus 3. So here we should multiply 3 and 3. That is why. Instead of here, we can take down here. So what happened is minus 3 by 6. Now consider the sum and the product. Both the denominators are same. Therefore, here consider here A value is 6. A value is 6 and B value. Look over here. B value is 7. Means it is already minus. So and C here it is minus 7 because it become minus. In the equation it is equal to minus B by. So that is why minus sign. But here it is plus 7. So that is why C is equal to minus B. So put these values instead of taking the minus sign over here, because already it is there. In the equation is also there. Don't put here. So that is why A value 6 and B value 7 and C value is minus 3. So hence the solutions relates the coefficients. Observe carefully. A6, B7, C minus 3. It means these relations are directly related to the zeros of the polynomial. By observing these two examples, what I am going to conclude, any zeros of the values are directly related to their coefficients of the polynomial. Now consider the fourth solution, example number 4. 4u square plus 8u. It is also polynomial. Consider it is a linear quadratic or cubic. Yes, of course the degree is 2. Highest power is 2. That is why it is a quadratic polynomial. Of course, it is ax square plus bx plus c. But c is not mentioned over here. That is c is equal to 0. So that is why. Now simplify. Means take the factor forms. Here 4 is the common. Again u is the common. 4 and u are the common factors. Yes, yep. So what is left now? 4 can cancel u. Only u left. Next 4 can divides by 2. That is u cancel. So u plus 2. Consider these are the two factors of the given polynomial p of x. At what value this p of x becomes 0? That now we can find. That is 4u is equal to 0 or u plus 2 is equal to 0. Consider 4u is equal to 0 or u plus 2 is equal to 0. Hence, your value of u is equal to, u may be any variable, not only x and y. Instead of x and y, you may use u, s, t, p, q or anything. So that is why u is equal to 0 by 4. Means this value is equal to 0. One value came, that is 0. Another value u plus 2 means u is equal to minus 2. Therefore, the final values are 0 and minus 2. Now consider their relations. Alpha plus beta is equal to, what happened its value? 0 plus of minus 2 means it is minus 2. And consider their alpha into beta. Alpha into beta, that is 0 into minus 2, it is equal to 0. So what is their values of a, b, c value? Consider this can be also represented as minus of 8 divided by 4. I may write this integer into fraction form. Why I written directly like this? Consider minus 2. Its equivalent fraction may be anything. That is minus 8 by 4. In the same way, we can convert this one as 0 by 4. Because any something 0 or something divided by something, it is equal to 0. Means 0 divided by something is 0. So that is why. Consider here 8 is equal to 4. Look their sign also. 4 2s are 2. Minus sign is minus sign. So that is satisfied. And b is equal to, here it is 8. Okay. Here it is 8. But in the equation also 8. That is why. Means it is minus 8. Become minus into minus. Here it is equal to minus b by a. Minus into minus become plus, hence it become 8. And c is equal to 0 because c value is not available in the equation. Therefore, these coefficients, observe carefully, a, b and c, their values are directly related to the given zeros of the polynomial. How? The sum of the zeros and the product of the zeros of a polynomial is directly related to the given constant k value, that is minus b by a and c by a. Consider this c by a. Hence, I took c value as 0. So, based upon these 3 examples, now you are able to solve the remaining problems. Try to solve. This is for your today's homework. So, this is today's class. Thank you.